Welcome to another episode of the WAN Manager podcast. I'm your host, Bryan, and this is the show where we talk to networking experts about the data services that make business possible. So today we're going to talk about the cloud. Obviously, that is far too broad a topic for a single podcast episode. Heck, probably even a single podcast season. But we're going to narrow that down specifically today to cloud outages, how to avoid them, how to mitigate them and deal with them once they inevitably potentially happen. When we look at this through the lens of the WAN Manager, we've covered this on our WAN Manager survey. And of course, a major facet of this, as we're going to get into this conversation, is going to be multi-cloud. Even back in 2019, in our WAN Manager survey, we found that about 3 in 4 enterprises were technically multi-cloud. We asked the question specifically about infrastructure as a service providers. We also found that the majority were in a hybrid cloud situation, so some mix of on-premises data, public-private cloud. Mixes were varied, but most people had moved at least part of their data centers off of their campuses. And of course, no surprise to anyone listening, most of the folks that we talked to were using both AWS and Azure, some mix of all of the others kind of in that list. But I'm going to guess that even being hybrid, being in those multi-cloud situations isn't enough to avoid some of the issues that can come from cloud outages. And so for that, to explain that whole process to us, very, very detailed, I would like to welcome to the show the CEO of Go Cloud Careers, Mike Gibbs. Welcome, Mike.
Thank you so much, Greg. I'm so happy to be here today.
Excellent. Yeah, thanks for joining us. I'm really excited to learn a lot here because this is not a topic that I've delved into too deeply. Before we get into that, Mike, I think it would be useful for you to just kind of go quickly through. You have an extensive background in networking and cloud, and then a brief intro on what you're doing over at Go Cloud Careers.
Sure, Greg, and thank you so much. So a little bit about me. Ever since I left healthcare approximately 25 years ago as a nurse practitioner, I've been working in networking, enterprise architectures, and cloud computing, and I've loved every last minute of it. I went into networking and I became a CCIE back in 2000. In fact, my CCIE number is 7417, which shows you how long I've actually been in networking. Back when it was a 2-day exam that had like a 90% failure rate. That was when I did it. And I got to tell you, that was the intro to networking for me.
Mm-hmm.
And I know that I had to read about 75,000 pages to get there and do about 400 hours of labs to actually pass that thing. That was when I began to learn networking, because it was only after that that I was exposed to the big projects that I actually got to learn things. So I was really lucky. I got to work on Wall Street, and I designed the network for the largest market maker on the NASDAQ. I got to be the lead architect on one of the world's largest banks, designing their voice systems. I've consulted to about 7 of the 10 world's largest internet service providers. And I've been a lead architect at Cisco and their healthcare vision for about a decade.
Mm-hmm.
I was a lead architect at Comcast, responsible for their network backbone. I was a lead architect at Riverstone Networks that was consulting on IP video solutions. So all in all, I've been designing systems for about 25 years now. And I got to tell you, after leaving healthcare, going into tech, I don't think I've ever worked a day in my life. It's been the most fun thing.
That's excellent to hear. Yeah, well, and it's really interesting for this show, right? Because you're going to be talking about cloud, and cloud can be its own IT specialty, but you're clearly coming from that kind of WAN network-oriented background about it, right? So,
well, that's the thing. The cloud providers, and I love the cloud, but the cloud is nothing more than a network and a data center that's been virtualized.
Mm-hmm.
And when we really look at what we do as cloud architects, we take the stuff, the servers, the storage, the load balancers, and we just move it to the cloud, which is just a virtualized network in a data center. So it's nothing new. In fact, our network architects have been doing cloud work forever. The first cloud I worked on was in 1997. It was called Frame Relay. The next cloud was called ATM, and we had these 53-byte cells that we're using, these optical links. And then the next cloud that I worked on was the BGP VPN, and specified in RFC 2547. And then my team at Riverstone was working along with Juniper and others to create the VPLS cloud. Now, those are 4 clouds that I'll give you that are over 20 years old. And, the cloud is not new. It's just this now. It's like, okay, then we just virtualize the network and the WAN. And now we're virtualizing the network of the WAN and the compute. So cloud computing is just renting somebody else's data center.
Right.
And that's the simplicity of it.
Yeah, I always love to say that there is no cloud, only other people's computers and wires, right? So yeah,
Yeah,
yeah.
but I think there's a lot of confusion. And before we get into the topic, I want to talk about why there's confusion.
Hmm.
So virtualization was invented by IBM, about 50 years ago to timeshare mainframes. And
Hmm.
then VMware did it about 20 years ago. And when you're dealing with old drugs, the marketing companies, if they want to rebrand them, they come up with a fancy name. And when you're dealing with cloud computing, it's really hard to resell 50-year-old technology. So those of us that are familiar with computing, we go to VMware ESXi server and we create a virtual machine. Now, the cloud providers don't want to call it the virtual machine because it's hard to sell 50-year-old technology as brand new. So AWS made up their own term called Elastic Compute Cloud for virtual machine. And Google made up this fancy term called Compute Engine Instance.
Hmm.
And only Azure and Oracle actually call it a virtual machine. So what happens is when we start looking at the network in the data center, as we've taken these terms that are so simple that we all understand, and we've obfuscated them by coming up with fancy marketing terms, that's why everybody's concerned. They don't know where to stick their storage. They don't know where to stick their servers. They don't
Right.
understand any of it because the cloud providers made it clear, like, hey, wait, this is a special service, Elastic Compute Cloud too. And they could have just called
Hmm.
it virtual machine and then everybody would know. And by making it complicated, we all forget the standard network and data center things that we know. And because we
Hmm.
forget, we make silly decisions. And that's where all these outages, problems, and security hacks that occur every day and the cloud, especially with regards to object storage buckets. That's why they're coming from.
Excellent. Well, yeah, I think explaining all this, it sounds like that's what you do. Could you maybe, before we get into the main topic, tell us just a bit about what Go Cloud Careers is and what you're doing on this kind of topic every day, right?
Yeah, thank you so much, Greg. So, for about 20 years, I've helped people find their first tech job or get promoted in tech. Now, about a year ago, I wanted to help somebody get their first tech job. In fact, my friend said, my kid's ready to graduate with a computer
Mm.
engineering career. And he's like, Mike, I've seen some of your interns. He's like, your interns are amazing. And I want my kid to have one of those jobs. So, what I did was as follows. I was doing private coaching. I basically bought him the top three selling Amazon courses. And the
Hmm.
nice young man called me back after 3 days and said, Mike, I set up an EC2 instance and an S3 bucket. And he said, what is it? And I said,
There
what do
you
you
go.
mean, what
Yeah.
is it? You just
Yeah.
configured it. He says,
Mm.
I don't know what it is. So what did I do? I watched these three best-selling courses and went, oh my God. They just told him the name of something, how to configure it, but they didn't even tell
Hmm.
him what it was. And then I
Right.
was thinking from an architect perspective, how do you design a system that you have no idea what it is? And the answer is you can't. And so what I did is I made a YouTube video that says how to get your first tech job.
Hmm.
And within a few minutes, I had so many requests saying, Mike, please help me get hired. So what I did is I took my 20 years of private helping people get hired program and I created our Cloud Architect Career Development Program where I take people regardless of their background and I teach them to be cloud architects. And if they've worked in tech before, it takes me about 4 months. And if
Hmm.
they've never worked in tech, it takes me about 8 months. And I learned how to do this when I went from medicine to network architecture 25 years ago. So I've been a
Hmm.
specialist on career transitions and I train people to be hired. I don't just train them in the tech, I train them in the business acumen, the leadership skills, the communication skills, the executive presence, the CXO relevancy, the ability to do an ROI model, the ability to negotiate through the work of the Harvard Negotiation Project, plus the Chris Voss negotiation work we use, how to present, how to write up an architecture. What we did is we put this 500-hour comprehensive architect program, and I train cloud architects, and I have students literally speaking in every continent except for Antarctica, and they get hired every single day. We have a little bell that I ring. It's like, okay, I'm ringing that bell, and each time one of my students get hired, it still brings tears to my eyes. Even they could think after it happening every day, it'd be no big deal. But I got
Hmm.
to tell you, taking somebody that's in poverty and seeing prosperity after an
Hmm.
8-week course that I charge basically a single day's pay because I don't need to work, that
Right.
makes me
Right.
happy.
Yeah, that's awesome. That's awesome. And sort of now bringing us into our topic of the day, cloud outages. Very much, along those lines, I think it would probably be appropriate for you to explain first what do you mean by cloud outages? How can that present itself in the real world to someone working at, say, a sort of enterprise networking IT team?
Yeah, so Let's say we start traditionally, and then we basically say the cloud. So many of us in the traditional data center have seen the network, which is the foundation of all services, go down. Maybe there was a routing loop, maybe there was a software bug, maybe it was a layer 2 network where spanning tree was doing something goofy, and all of the systems would go down. And then we networking people would be there, would be shutting off routers, taking protocol analyzers and looking for data to try and figure out what's broken so we could fix it.
Mm-hmm.
Now, the cloud is nothing more than a standard network or a data center. So if there's a problem in the data center or the cloud, guess what? That whole data center goes down.
Mm-hmm.
Now, the same thing with the switches, same thing with the router, same thing with the servers, but it's worse than that. See, in our data centers, the only kind of control plane we're really dealing with is the network and the routing protocols. In the cloud, we now have the network, we now have the control plane of the cloud, which is what orchestrates the cloud.
Mm-hmm.
So we've got these servers that every time I create a virtual machine goes, hey, go to server 697, go to server 622, use block storage associated in this part of the data center, use block storage associated with someone else. So now everything's dependent upon the network, and not everything's even in the same data center. So now when that network goes down,
Right.
you can lose everything.
Mm-hmm.
So, with the cloud, we've got the cloud provider. Now they've got redundancy in their networks. Theoretically, they've got, separate data centers. And of course, they've got separate regions. And theoretically, they segment them. And the theory is if a data center goes down in the cloud, guess what? You just back up to another data center. But Azure had a massive hacking event this year and had a pretty significant outage, and thousands of users were compromised. Google had a pretty bad network outage that affected a tremendous number of users.
Mm-hmm.
And AWS has had massive outages. And the kind of outages that AWS had affected users in every region of the world. And, like we've told people forever, it doesn't matter if you have a massive problem in the middle of Kansas. It can ripple throughout the world if it's on the same
Right.
network. So
Mm-hmm.
you've got a network, single control plane. That control plane gets hacked, your cloud's dead. Like all of it, the whole cloud is gone. The cloud gets hacked and it affects the network, DDoS, the whole cloud can be gone in every region in the world. You get a network failure, guess what? The whole cloud can be gone. So, that's why we're talking about hybrid clouds and multi-clouds, because Greg, you and I have built WANs forever. If we were going to connect New York and London, we're not going to get two AT&T links to New York and London. I love AT&T. It's a great service provider. And the reason we wouldn't do two links is, look, we might have an underground cable, which one gets cut and the other works, and we'd be happy. But if AT&T has a global outage, we lose both links, and we've got no connections between New York and London. So we might use AT&T on one link and British Telecom on another link. And the reason we do that is redundancy. So our philosophy is the single cloud is just like a single service provider, a single point of failure. And we'd be never crazy enough to do this with the WAN. Cisco advised us for decades not to do this. Juniper advised us for decades. Heck, even the service providers themselves buy links on each other's networks and advised us against this. And now we've got cloud providers that are service providers that are saying, guess what? We've miraculously figured it out. Put all your eggs on one basket and we're fully diversified, until they're not. And we've seen time and time again that they're not. So I think we need to revert back to the strategy that we've preached forever. Redundancy. Two is one, none is none. One is none.
Mm-hmm. Absolutely. Yeah, that makes sense. And so from the perspective now, there's a conversation here that could be had with the cloud providers, but of course we're talking to the folks using their services. So knowing that we probably can't change the way that AWS and Azure and Google and whatnot are going to sort of engineer their networks, what can we do on the IT infrastructure team at Enterprise XYZ's side, right?
Okay, so there's a couple of things. So I do want to note that Google's now out there saying, hey, everybody, you can't use a single cloud. You should train your engineers to work on. Google knows that. So Google's the first major cloud provider that's saying, hey, wait, this is bad practice. Don't do it. And we're here to guide you. But, it's like anything else. So when we connect to cloud providers, they like to tell us that their router on their end is redundant. So all we need to worry about is a single router on ours, because it's going to create two logical connections.
Right.
Now, that's what they tell us. But if our router dies, has a bug, power outage, or crashes, then we lose both connections to the cloud. So clearly that's not it. So what do we need? When we connect to the cloud, we need redundant routers and redundant connections. So For example, go back to the military adage: 1 is none, 2 is 1, and 3 is greater than 2. So I would probably use 2 routers for most of my customers that are connecting to the cloud provider. We're using BGP, which is the world's simplest and most tunable routing protocol for scalability. And I make sure that those routers that I'm using have multiple power supplies across different circuits, because we can't have a power outage affecting our systems. That just doesn't happen in reality. And of course, those circuits are going to be plugged into 2 different power distribution units, which are going to be plugged into 2 different UPSs. They're going to be plugged into 2 backup generators. So the point is, we don't have power outages in real data centers. So we've got that. And then we're going to put links on multiple line cards. So if a line card would fail, guess what? It doesn't matter. And of course, with these routers that connect to the cloud, remember, if we're connected to the cloud is everything. We're going to put 2 control modules. So we can basically lose the router's brain. We can lose a power circuit, we can lose a control module, and we've still got 2 links. And you know what? I'm going to have a second router that connects to the cloud doing that too in another region. And I'm going to have 2 more of those to go to 2 clouds. So my network is solid. Now, of course, I'll firewall off my clouds from each other, limit my routing information, maybe add some QoS to the WAN links in case we get infected with a worm, for example. I don't want that worm traffic overwhelming that WAN link to the cloud. So, that's how we do it. And really then, it's no different than a hub and spoke environment where I connect to an office in New York and an office in San Francisco from my home in Palm Beach. Same thing. It's identical. Same BGP routing. And if I wanted to, I could even store everything I had in my own data center and share that information across my high-speed links to the cloud. And guess what? The cloud, you don't pay to send your data to them. You pay to retrieve it. So I literally speaking could have all my servers on both clouds working off of my data center and not even pay to send the data there.
Right.
Because that's one of the things I hear about is, where do I stick my data on every cloud? I'm like, you could stick it here, you could stick it there, you could stick in this location and build a high-performance network. It's simple.
So the decision more about sort of how you connect to that rather than sort of where you're putting your data, or even if you're multi-cloud in a sense. Obviously, you're saying you should be multi-cloud, but really, even if you're multi-cloud, you need those redundant connections to all of your multiple cloud providers.
Absolutely. And I love hybrid clouds, actually, because I feel like the hybrid cloud is truthfully the best solution. And I love multi-cloud. I love hybrid cloud. The reason I like the hybrid cloud better is when we go through across a WAN, we've got latency. And when we're on the WAN, we're using block storage in the cloud, which is really low performance. For example, an AWS provision IOPS volume, which is a high performance cloud networking volume, gives us 64,000 IOPS. But if I go to Best Buy and buy a Samsung 980 Pro, which is a standard hard drive, we're dealing with about 1 million IOPS. So just one of them can be as fast as 15 of the fastest hard drives in the cloud. Now on our servers, we can stick them in a RAID array. So we can combine 8 of them and we can get some extreme performance. So we can actually get better performance in the data center. We've got much less latency in the data center. And we've got a lot more control over ingress and egress in the data center. And we've got less security things to worry about in the data center. So we've got our data center, which is super high performance, and that's connecting to 2 clouds. If both clouds go down, we're still there. If a single cloud goes down, we're still there. And by doing that, it's imagine. So imagine if, for example, a 911 system or a hospital was on the cloud when these outages occurred. Somebody could die. And, I've been a paramedic for many years. And I was a nurse and a nurse practitioner before I went practicing internal medicine, before I went into tech 25 years ago. And let me tell you, if your systems are on the line, emergencies happen and bad things will occur. So that's why we really have to think about, what are we architecting for? What is it? Is it mission critical, not mission critical? And if it is, we got to listen to the people that have taught us how to build high availability mission critical systems. No single points of failure.
Right. And so there's decisions there, right, to be made about if you're in a hybrid kind of situation, working with the broader IT team who's using that compute, that data storage, order to determine what goes where, right? Do you have recommendations on a kind of process for making those decisions from the infrastructure or data center side of things for the rest of, especially organizations that have maybe shadow IT kind of stuff going on and whatnot, right? How do you navigate all of that?
I always start, now there's 2 kinds of architects. There's the technical kind of architect and the more enterprisey kind of architect. I'm the more enterprisey kind of architect. I like to start at the CIO, CTO, CEO. And I like to really tell me about your business.
Right. Right.
Tell me everything that I need to know. Now, granted, I've read their financial statements, I've read their annual reports. By the time I got there, I know what the industry analysts are saying. I know what their competitors are saying, but I want to know, what is your business? And
Hmm.
here's the reason why. I worked with a financial customer one time, and basically speaking, they had an algorithmic training thing that a nanosecond of competitive advantage equaled about $40 million of profitability per year per
Right.
nanosecond.
Yeah.
And what we did is we took the
Yeah.
biggest, baddest servers we could we'd put them all in a rack with the shortest fiber optic cables as possible, with the
Mhm.
fastest, routers and switches and servers in the world, just so we can keep the CPUs at 5% to make sure there
Right.
was no latency. And, we had two redundant ones. And for that use case, it made sense. Why? Because we shaved out milliseconds by being
Mhm.
local, and that equated to billions of dollars per year. So for that can't go to the cloud. Now, maybe I've
Right.
got a customer that's got a lot of IP multicast, another financial
Mhm.
customer. Again, the cloud doesn't support multicast. So if I want to do multicast in the cloud, I've got to create all these GRE tunnels through the cloud. And again, that's not there. So what I like to do is look at the application. What are the latencies of the application? If so, if it's
Mm.
high
Mhm.
latency dependent, it's going in the data center, not the cloud, because the cloud's got more latency from the WAN.
Right.
Or maybe I can stick in the edge, which isn't as good as my data center, but it's much closer than the cloud. So maybe I stick it in the edge. So for me, it's all about, what is the business? What is the
Mhm.
business goal? What is the business performance? What are the applications tolerated? I don't know that until I ask questions. Now, I wish I could say that I was on the kind of networks and clouds architectures that normal people are, which is, hey, please help me set up my 3-tier web architecture or my
Right. Right.
database. But in 25 years, I don't get asked for these things. I get said, hey, we're building a bank. Nobody's ever done this kind of digitally enabled bank before. Mike, would you like to consult? Which is like, oh, okay. Let me go find the 50 smartest people I know to bring with me to help me do
Yeah.
it. So for me, that's why I don't have standards. But what I'd say, it's based upon the latency, the bandwidth, and performance requirements of your data.
Yeah, absolutely. I love that, and it really kind of fits with the tagline of the show, right? Of the networking that makes business possible. That it's about seeing the network as the business enabler rather than just reacting to what folks in IT ask the network team for. You know.
It's exactly it. It's funny, when I worked at Cisco about 18 years ago, they realized that selling boxes was not the solution, that the sum of the solution end to end was far greater than the sum of its parts. And they
Mm-hmm.
started asking certain engineers to be instructors of the service oriented network architecture, which was a business driven architecture. And when I was at Cisco, I was selected to be one of those coaches to basically train the engineers in that. And, 20 years ago, they were there. They were looking at how the network could enable digital transformation. How did that network enable two people to talk to each other? How did that enable someone in Mexicali to speak to someone in Chicago so they could collaborate? How could it enable a data center in Bangalore and New York? And when that became popular and the WAN enabled that, it changed everything.
Mm-hmm.
So yes, the network is the enabler of all things. I'm 100% with you, Greg, and that's exactly the way I look at it.
Yeah. Yeah. Absolutely. So, at TeleGeography, as a research shop, we're particularly kind of focused on layers 1, 2, 3. And so one of the things we're often doing research on and talking to enterprises about is actually how you choose to connect to the cloud, different transport options, and especially in now the SD-WAN world, we've moved away from MPLS being the kind of default for most enterprises. Do you have any recommendations there around what your underlay selections might be, from the office to where you pick up, that first mile connection to your cloud provider? What do you think are some best practices there with sorting out, among all of these various options, especially in this hybrid, not cloud, but hybrid networking kind of world that SD-WAN brings about?
Yeah, and it's kind of interesting. I still see a tremendous amount of Ethernet over MPLS.
Hmm. Hmm.
A
Absolutely.
tremendous amount. And I'm still seeing predominantly private lines, believe it or not.
Hmm.
Whether you
Hmm.
call it an Express Connect on Azure or Direct Connect,
Right.
basically you're buying a gigabit Ethernet port to something, and then they layer to backhaul you back to their systems.
Hmm.
I'm actually seeing predominantly IPsec VPNs,
Yeah.
when realistically speaking, if speed and performance doesn't matter, and you're just trying to
Hmm.
transfer your things, you don't have latency. I see VPNs and I see direct connections. So I'd say
Hmm.
80% of what I'm still dealing with is actually just old school
Just layer 2,
1980s
point to
connect.
point, or yeah, yeah,
Now,
absolutely.
software-defined networking, and that's not really my world. I've been in networking forever. I built my networking career initially. I spent my first 10,000 hours working on nothing other than BGP, and my next 10,000 hours doing IP multicast video. And then after that, I basically became more the business architect that was architecting the world's largest customers. So
Right.
SD-WAN was not something that I still, the concept of separation of that control plane and data plane, being able to
Right.
provide MPLS like privacy, performance, and security, it's coming. And the cloud's a little slow to adopt new technology. I mean, really slow. For example, AWS just announced routing in between subnets in September of this year, which Cisco was doing in like what, 1985.
Right.
So when we start looking what's going on in the cloud, each day there's a new press release, but it's getting us closer to the functionality that we had 15, 20 years ago in the data center. So, it's going to take us a little while to get the WAN to the performance that it was in the network in the data center for the cloud, from what I'm seeing.
Yeah, absolutely. Yeah, that's a really interesting take, I think, on all that, because sometimes it can very much get lost in kind of what you mentioned at the start of that. That there's new ways of talking about some of the same technologies that have always existed, right? And so,
Yeah.
and not to say that sometimes there's not some sort of distinction that is worth digging into, but that we're not reinventing the way that computers talk to each other with
No.
every one of these innovations, right? Yeah.
If it's a private line, a direct connect, or an express connect,
Hmm.
it's a private line. To
Right.
me, it's always going to be a private line. When I talk to my customers, I'm going to talk about a private line. I'm not going to tell my customer I can set you up an express connect, because they're not even going to know what it is.
Right.
They're going to look at me like I have four heads. And if I said, hey, I can set you up a direct connection, or they're like, is that a private line? I'm like, yeah, it's a private line. So, I think we need to, I'm a fan of using plain and simple language. If you're giving me a postage stamp, call it a postage stamp. If I get in a car, it's a steering wheel. It's not an elastic rotational directional changer. And as long as I keep it
Right.
something that I can understand and my customers understand, we're speaking the same language.
Yeah, absolutely. And just like you say, in the end, someone has procured a wavelength or a layer 2 point to point between nodes, and you have traffic going over that, right? It's like at bottom, it is still just wires between machines, right? So yeah,
Exactly.
absolutely, yeah. Bring that up, actually, it's interesting because there's a phenomenon going on in the security world, right? Sort of like SASE, and there's a lot of what you might call SASE washing of folks taking security technologies that have existed for decades in some cases, and fitting that into this sort of SASE framework. I think this is probably a topic we could do a whole episode on, but just
Absolutely.
as it kind of relates to the sort of avoiding outages and mitigating them or whatnot, do you have any kind of security recommendations that come up when you're talking about this with students or clients and that sort of thing?
About SASE security or about general cloud security?
Yeah, about general cloud security, because
Yes.
we'll deal with SASE as a particular. I just brought that up because of the sort of common security techniques being brought under this moniker of this new framework, when
They scare me
yeah,
in
exactly,
every
right.
way.
Yeah.
So, and actually, it's interesting because the SASE firewall thing is pretty interesting. I used to work for a
Hmm.
company called Riverstone Networks,
Hmm.
and they had these two engineering folks that ran the organization, Kumar Mehta and Apurva Mehta, and they started Versa Networks. And I got to tell you, every time I speak
Yeah.
to them, that SASE solution is very elegant. So when I speak to
Hmm.
those folks at Versa, I'm loving it. But here's the thing: when we're going to be on the cloud, we have cloud security options.
Hmm.
Now, the cloud has these little native tools. Like AWS has something called WAF, a web application firewall. And what it is
Right.
AWS made us, a firewall for web applications.
Right.
Now, if I had an enterprise to secure, and AWS made this firewall a couple of years ago, and I got to say, wait, they're the world's largest retailer and they're a cloud provider. Well, are they my number one security go-to company? And the answer is
Hmm.
no.
Hmm.
It's because it's not their core business. Now, Palo Alto, security is their core business.
Right.
Fortinet, security is their core business. Cisco, security is one of their core businesses.
Hmm. Hmm.
Checkpoint, security is their core business. So If I look at a layer 7 firewall that only protects a web application that I can get from a cloud provider, or a robust next generation firewall from Cisco or Palo Alto that's going to come in,
Mm-hmm.
that's going to protect me at layer 3, 4, 5, 6, and 7,
Mm-hmm.
something that's had billions of dollars of research and development, something that's been tested by the world's most critical customers with regards to security.
Right.
That's what I'm using in my systems.
Right.
And why? Well, first, it's going to work better. Secondly, it's going to give me a much better feature set. But third, I can use that same Cisco firewall on Azure and AWS and my data center. And now I can run a real security policy. Because if I was going to do multi-cloud, and then I'll tell you the rest of my security policy, if I used AWS's branded, whatever they made, and I use Azure's branded whatever they make, I've got 3 different sets of firewall policies. And if AWS's firewall gets hacked, it's a backdoor into my system. So what I typically do is as follows. I typically take a content delivery network for web apps. Why? Because the content delivery network will give us some DDoS protection, and I add some DDoS protection to it. And that way, only legitimate requests will be forwarded to the server. Next thing that I typically do is I have a network load balancer. Now, in the data center, I can have my 2 high availability firewalls there. But in the cloud, I can't go rack anything there. So because I can't do it, I've got to use virtual machines. No, virtual machines are not mission critical, high performance devices. So I need something to load share, basically meaning if one of the virtual machines dies, I need to remove it. So I typically use a network load balancer to load balance in between my firewalls. And that way, I'm in the cloud, I have my content delivery network, I have my firewalls, which are load balanced. Now, I'm going to use next generation firewalls, which are also going to have an intrusion detection, intrusion prevention. Now, I might still need so much security that I want a secondary intrusion prevention device. So I might take another set of network load balancers and stick another set of virtualized IDS IPS systems. Then beyond that, I've still got a lot to do. I haven't even scratched the surface of security. Now, on my routers, I can create an access list to filter in between subnets. And on the cloud, I can do a network access list, which is a layer 3 access list, which is basically a stateless way to keep traffic out of your subnets. Now, the cloud providers also give us something else. They give us like a stateful firewall on the way into our services. So we can say only port 443 or HTTPS is allowed in the server. That's called a security group. So we're going to have our firewalls, which are next generation, our IDS IPS systems. Then we're going to have our network access control list or access control list. Then we're going to have these security groups. Then on our servers, we still haven't scratched the surface. Our servers can be hacked. So what are we going to do? We're going to put another firewall on the server, a host-based firewall. We're going to put some anti-malware protection. We're going to disable unnecessary services so we don't have any open ports. And then, again, we're going to patch these systems. Now, that covers some of the security, but not all. We should be encrypting our storage. We should be using some kind of a AAA authentication, authorization, accounting, or identity access management to say that Greg is allowed on the systems. This is what he is allowed to, and then keep track of it when we're done. And reality is, in today's world, we can do some event-driven security. We can basically have our logs kick off like a little mini code function or to remediate something. In AWS, they would call it Lambda. Azure would call it a function. So we can basically have somebody do something goofy. We can have our logs kick it off, and we can automatically remediate it. So that's kind of part of what I like to do. And the other thing that I like to do is I like to aggregate the logs. Greg, you've been around. You know how you've got thousands of logs that are coming in. And for the customers that really want to do something cool, we can take their logs. We can actually push the logs through a machine learning engine. And then we can use a tool like Tableau or Power BI to visualize what's going on. So we can visualize things going on our networks. And that's pretty much my typical security architecture. Again, it's far more than the typical that they would teach you in a certification, just add a WAF and shield. But customers need security, and this is what I use. And this is my typical recommendation on anybody that needs high performance security. And that same thing I can do in my data center and as many clouds as I like. So I have matching policies.
Right. That's really key, right? To be able to orchestrate it all very easily. And it sounds like you're talking probably about several different vendors being involved in all of this, right? So
But it's the usual suspects. Who do you go for networking? Cisco or Juniper. Who do you go for firewalls? Cisco, Palo Alto, Fortinet for the most part. I mean, that's who you're going to go to. So who are you going to go for databases? Oracle. So basically, instead of using any of these cloud things the providers made themselves, just use the industry standards. And then you can get on and off any cloud you want, anywhere, anytime. You're not locked in. And in some cases, it's even cheaper.
Yeah, absolutely. It's I think that's a a big theme for everything that you've been hitting here is avoiding that vendor lock-in, finding the best in breed, and putting the solution together based on what works, rather than sort of a stack that sounds nice and easy, right? So yeah,
Yeah.
yeah,
And everybody has bugs. It's just part of
hmm,
life. And by having
right,
this discrete equipment, you're kind of immune to some of those bugs. So it
mm-hmm,
gives you a lot more flexibility, a lot more agility. And it's just that vendor lock-in. I mean, that's really bad. I
right,
mean, as
right.
it stands right now, I remember I actually saw an executive tell a customer that the press release they issued cost the company $1 billion a year. And
Yeah,
I remember watching the executive tell this customer in horror, because I was thinking, okay, great. Somebody's going to have to sell this customer now their new services. And now the customer knows a bad press release cost the company $1 billion a year. And I saw that once in my
right,
career and went, oh, but that's the key.
hmm,
If I'm on two clouds and Azure wants to raise my rates, for example, I just flip the coin, Azure, AWS. Azure raised my rates. I can say, Azure, you know what? You really want to raise my rates? I'm going to go to AWS. I'm going to issue a press release that Azure raised my rates and I want to get AWS. Now, will
right,
Azure be raising my rates? No. Azure will
hmm,
say, what's it going to take to keep you here? Because that
right,
press release could be worth billions of dollars a year. It could be AWS that raises the rates. It really doesn't matter. But the point
right,
is you've got protection, negotiation power, buying power.
hmm,
Otherwise, you're just, especially if you're cloud native, you recode all your apps in the cloud. They're like, you can't leave me. It's going to cost you millions and millions of dollars to leave and months to get out of here. You can't leave, so we can do whatever we
right,
want. It's up to
right,
you how you
exactly.
architect your customers, but I like to give my people freedom.
Hmm. Hey, it's not that different than calling the your ISP and threatening to leave for your home connection, right? When they raise the rates suddenly after your
Same
introductory,
thing.
yeah, yeah, yeah,
Same
absolutely.
thing.
Excellent, Mike. Well, this was really interesting conversation. I've learned a lot. I much appreciate your insights. Any kind of final thoughts or key takeaways on avoiding and mitigating cloud outages or the security piece?
Yeah, absolutely. It all comes down to basic networking and data center technologies.
Yeah, I think that. I mean, I want to highlight that for you. Sorry to interrupt, but that really to think of this as this is a network, and you're doing network engineering. It is not this whole class of different thing, right? So,
It's just network and data center technologies.
hmm,
And when people say, Mike, I'm certified in everything, I can't get hired as a cloud architect, I ask them, tell me, what is a virtual machine?
hmm,
Describe it to me. Talk about the hypervisor, the memory management, and they can't. When I
hmm,
say, explain the BGP decision algorithm, and they say, why do I need to know that? And I say, well, if you have a direct connection or a private line to AWS, you must use BGP. AWS tells you if you have two links, block one link so that you don't have out of order packets. But after 25 years of networking, I don't know that any customer wants to buy two links and have to block one. They're going to want to
hmm,
load share by sending one subnet on one link and another one, and they still need out of order packets. So what they
hmm,
teach in the AWS advanced networking is just block a link. I mean, that's not reality. So what
hmm,
I'd say is, for those working in the cloud, get your fundamentals strong.
hmm,
Learn the network, learn routing, learn switching, learn IP addressing, learn route summarization, learn NAT, learn VLANs, VLAN tagging, VLAN trunking, etc., etc. Learn servers, server architecture, containers, container architecture. Storage. What is block storage? How does it work? Why does the company use it? The business benefits. Same for object storage, file storage. Learn DNS for real. Learn how the DHCP messages work for real.
hmm,
Learn about your WAN technologies, how they work for real. Learn about the types of load balancers and how they work. And then we get to the cloud, guess what? It's all the same. But now
right,
we have the deep knowledge of the inner workings of it, as opposed to the hidden stuff. And what is the cloud really? The cloud just means you don't know what it is.
right. Exactly. I always say that the cloud is just the part that on a diagram that someone's using that they don't want to explain at this time,
Exactly.
right? So, yeah, exactly. Yeah. Excellent. Yeah. All right. Well, that was like I said, really interesting conversation. I think that we all are listening to this going to learn something useful. If folks want to learn more, Mike, how should they find you?
They can find us at www.gocloudcareers.com, or they can find us on our YouTube channel, which is the busiest cloud computing channel anywhere on YouTube, which is
Mhm.
Go Cloud Architects. So we'd always love to talk to people. We're thrilled to be here on with you, Reg. And the concept of a WAN podcast, we love it. We've seen other podcast episodes. They're fantastic. They talk about networking technology, which is my favorite thing in the world.
Yeah, awesome. I mean, that is definitely clear. So I appreciate you taking some time out of your busy talking schedule. I understand you're on YouTube for hours a day generally. So, thanks for taking some time to lend that voice to over here at the WAN Manager podcast.
So happy to be here, Greg.
Excellent. Cheers. We'll do this again sometime.
I look forward to it.
Thanks for listening. The WAN Manager podcast comes from the team at TeleGeography. It's edited and produced by Jane Miller, and it's hosted by me, Greg Bryan. I also wrote the theme song that you're listening to right now. To learn more about our data, jump over to telegeography.com. Or if you want to get right into more WAN content like you hear on the show, you can visit TeleGeography's WAN forum at wanforum.com. We've got all of our podcast episodes over there, WAN Manager survey data, and extra analysis pieces. That's all for now. So until next time, WAN enthusiasts,